Hello, I'm Anika Viswesh. I'm excited to introduce our next speaker, Dr. Dieng, at the Africa Science Buskers Festival 2021. Dr. Dieng is a Senegalese computer scientist working in the field of artificial intelligence. She received her PhD in statistics from Columbia University, where she was advised by David Blay and John Paisley. Her doctoral work at the intersection of probabilistic graphical modeling and deep learning received many recognitions, including a Google PhD fellowship in machine learning and a Savage Award. Dr. Dieng is the founder of the Africa I Know, a research scientist at Google AI, and an incoming tenure-track assistant professor of computer science at Princeton University. Thank you for joining us, Dr. Dieng. We are extremely thrilled to have you today at the Africa Science Buskers Festival 2021. Over to you.
Hi, everyone. Thanks for having me and thanks for tuning in. I'll try to share my slides. Okay, share screen. You let me know when you see it. You see it?
Yes, I see it.
All right, great. So let me do this. Okay. Does this work?
Yeah, I can see it. It's
great,
perfect.
great. So the title of my talk today is My Journey in STEM, Lessons and Hopes. I'm hoping to, talk about my whole journey and then discuss lessons that I learned throughout and try to give some, communicate some of those lessons and give some advice in case that can be helpful for anyone. So I work in the field of artificial intelligence. I know you've all heard about it because it's breaking into a lot of industries and making a lot of impact. So I wanted to discuss that journey. I grew up in Senegal. It's in West Africa. The fun fact is that it's the westernmost region of Africa. It has 16 to 17 million people. It's politically stable and peaceful. Also, not a while ago, I made these slides way before that, like 6 months ago. There has been some politically driven violence with youth protesting the government and things like that. But overall, it's known to be a peaceful and politically stable country. We have great food, sort of things I like. And unfortunately, the literacy rate of 15 plus years old, like in a lot of places in Africa, is relatively low, especially for girls. And there are two seasons, dry and rainy season. We don't have winter or anything like that. Just two seasons, either dry or wet, which is sometimes funny when I tell people. So this is where I come from. I come from a region in Senegal that's called Kaolack. It's towards the center west. It's sparsely populated and the temperatures, not as in Dakar. Dakar is usually like 25 degrees, 26 is really, it has really nice weather, but in Kaolack it tends to be very hot and humid. There are electric outages that are very frequent across Senegal, but mainly in regions outside Dakar, so Kaolack included. So I used to learn to study under candlelight, which can be, not the optimal experience for learning. There were scarce educational resources in Kaolack. There was one library that was called the Alliance Française. You had to pay to have access to the content from that library. Outside of that, there's not many, educational resources like books and things like that. So I remember back in high school, me and my friends used to like ask our elders who are a class above us for problem sets to solve because you quickly cover a lot of those things. And this is because there was no internet. You don't have access to computers or internet. I'm telling all of this just to remind that in some of these regions, it's not the most obvious thing getting like the type of education you can get abroad, meaning where you have internet and can look up a lot of things, have educational resources and all of that. And that this experience growing up has motivated me to start a nonprofit organization. I'll talk about it towards the end. But I just wanted to give context. I was the year before the end of high school. I was selected to represent Senegal in an excellence camp, they called it, for African girls in STEM. And that camp was organized by the Pathfinder Foundation, which was a foundation that was started and led by Dr. Cheikh Modibo Diarra. He's the first Malian and first African, I believe, to have been to work as a astrophysicist for NASA. So he's very influential. He went on to have a career in many fields, including politics in Mali, where he's from. So I attended the camp, and attendees of the camp had you get selected from people who attended the camp. You get selected if you pass the exam after high school. You know, the exam that when you pass it, you can start college. So you can pass that with certain recognitions. Depending on the recognition you get, if you get a recognition, you get selected back to participate in a competition for a scholarship to study abroad. So I was lucky to win that scholarship and decided that I'm going to study in France. And the decision that went there is because in France, they speak French, like in Senegal. Senegal was colonized by France. So French is the official language, the language spoken in the administration and at school. And so that was what went there. And also because France has a very strong educational system, especially in STEM, and they're very strong in math and some of the engineering fields. So I went there, I attended Lycée Henri IV. You know, they have two systems. They have the university system, 5 years, but they also have what they call the Grandes Écoles system, where you do preparatory classes and then you take an entrance exam nationwide. It's a nationwide competitive exam that you take, and depending on the grades you have options to choose from certain schools. The higher your grade on that exam, the more grade options you have. Basically, that's the setup. So I went to Lycée Henri IV and then got entrance to Telecom Paris Tech, which I attended. And there I got to learn, probability, statistics, statistical learning theory, and also computer science, things related to coding, algorithms, and data structures, and things like that. At the end of the last year of Telecom Paris Tech, you have the opportunity, like you do for when you attend many grandes écoles in France, you have the opportunity to spend it abroad, to spend it in a different school. I chose to come to the United States, so I went to Cornell Ithaca and spent that year there. I got the IAD fellowship, Institute for African Development Fellowship, to spend that year there. And once I finished that year at Cornell, I got my degree from Telecom, and then got awarded a master in applied statistics from Cornell. And after that, I decided that it was time for me to put things in practice, everything that I learned, to put that in practice. But I also had, Africa in mind and always wanting to do good for the continent. So I went to the World Bank to work on. I went to the World Bank in the market and counterparty risk. That's it's a corporate department within the World Bank whose goal is to maintain the AAA rating for the World Bank. Basically, if the World Bank maintains that AAA rating, they will be able to keep affording very low rates for the loans they were making, and very low rates in the financial market, which a lot of poor African countries don't have access to. They don't have access to the international financial market because of these default and things like that. And so the World Bank acts as an intermediary between some of these poor countries and the international financial market. And the department I joined, their role was to make sure that the World Bank will still be able to borrow money from the financial market at very low rates and then lend money at very low rates to poor countries. And so I worked on statistical modeling when I was there. But also I developed an add-in, Excel add-in for reporting purposes to automate things. And that was very beneficial. Then after 1 year in, I realized that, that's not the impact I thought it would have. And things were starting to get repetitive in terms of learning new things and growing. And at the same time, also machine learning was, I was hearing a lot more about the impact machine learning was having in the real world. I did take machine learning related courses in Telecom Paritech, but at that time it was just very abstract and theoretical. But at the World Bank, when I was there, I started hearing more about it and the impact it was having in the world. So I decided to start a PhD. I started my PhD at Columbia University, working with Dave and John Paisley. And going there, I knew that I wanted to do my thesis in machine learning, but I didn't know exactly in which area. So I took a class from both of my later super advisors, Dave Bly and John Paisley. And those classes were about probabilistic modeling, looking at how to build models to learn from data using a probabilistic approach, and inference, meaning how once you build those probabilistic models, how do you learn them? How do you learn them and make inferences about the world? So when I took those courses, I realized that that's exactly what I wanted to do. I wanted to do probabilistic modeling. I wanted to do generative modeling. I wanted to know how to fit those models to data so that you can make prediction while accounting for uncertainty, because the world is uncertain. And also accounting for uncertainty allows you to make safer inferences, which is what you want. And so, yes, I embarked in research in generative modeling, which was what my thesis was about. I also like generative modeling because it allows you to deal with unlabeled data. Why is that important? A lot of the data we encounter in practice are unlabeled. For example, speech data is unlabeled most of the time. Documents, you're just given documents. You're not given a label or anything like that. That's an example of an unlabeled data. Or you are just given items from a supermarket. For example, this is dog food, seasonal fruits. You have some food ingredients like tomato sauce, chips, beans, and things like that. So you're given item from a supermarket, and you may want to devise a model and algorithm that will allow you to see which item should go together so that you can place them better in the supermarket. So you can do a lot of things with machine learning, especially generative models, because it allows you to deal with unlabeled data, these types of data. So what is it? Basically, I'll go through at a high level what the process is. You observe some data, you call that X, and again, these data are unlabeled, so no one is telling you the tag for those. For example, you just given an image, you're not given a tag for what the object in the image is. You're given an image of a dog, you're not told it's a dog. That's an example of unlabeled data, but you still want to understand, to model the image, to know next time when you're given an image, you will be able to say whether the characteristics of that image. Maybe you can generate more image like that. This is just an example to fix the ideas. But basically, those are the types of data we observe. We call them X. They're unlabeled. You can think of them, we represent them in machine learning mostly as a long list of numbers. Each data point usually is represented as a long list of numbers. For images, it's pixels and things like that. You come up with a process that gives you some variable, something that we will call u, and you want u you will have the same length as X because we want to learn to generate X. That's what generative model is. You learn to generate the data, so that if you learn to generate the data, then it means that um, you have a process that can generate new data, that can make predictions, and that will allow you to understand what goes into generating that new data. So you'll be able to extract the structure underlying the data set. So you want to, once you have this observed data X, you want to come up with a process that gives you U. And this process involves quantities that represent the structure of the data. This structure can be a lot of things. For documents, it can be discovering the topics discussed in those documents and things like that. Um, for health data, it may be characteristics of patients, hidden characteristics of patients. So you can use that to predict diseases, to predict hospital readmission and things like that. And this structure, often in probabilistic modeling, we will call them like a latent structure, latent variables, and they tend to have to also be a list of numbers, but like of a shorter list of numbers, because we're trying to contract and learn these correlations. But U, the output of that process, has the same length as X. Now we build an algorithm, and this algorithm will basically learn anything involved in this process. And it does that by making U, the outcome of this process, the output of this process, close to X, the data. And that's what all it's about. These three steps is what most of machine learning is about. You have some data X, you come up with some procedure for generating X. That procedure involves new variables that you want to learn. And the output of that process, you want the output of that process, the variable that comes out of that process, to be close to the data. And that's what the algorithm will do for you. So you can do a lot of things with it. You can understand consumer choice. So here, this is a data set of 5.7 million purchases. So people go to the supermarket and they purchase things, what they put in their baskets. You take all of that, you build a model following this pipeline, and you can learn, the model will learn which items go together. So for example, here it learned that deep artichoke and deep spinach signature 16 ounces, they are close together in some space. What you see here is a space where a two-dimensional space, meaning any single dot here has two numbers characterizing them. And the red dots and blue dots are basically just items that were the positions for those items that the model learned. So the model has learned that cars cracker table, cars crackers table, water black, all these brands are close together, so people can buy them together and things like that. You can learn the meaning of words using the same pipeline that I discussed here. So here, what we did was, you have 1.8 million articles from the New York Times, and you define a model, an algorithm for that data, and you are able to learn the meaning of words. A meaning for a word is given by words that are similar to it. For example, for family, you see children, son, mother, father, wife. Health, you see benefits, medical care, association, drug. Religion, you see religious, spiritual, religions, Christianity, writing. So these are called word embeddings, and they give you an idea for what the word actually means. You can learn topics. You can learn to represent documents. You can discover how language has evolved over time, meaning how people have how discussions around certain topics have changed over time. So here we had the data set from the United Nations debate. So the United Nations, they have these debates that they have, and some documents are written, transcriptions of those debates were written. So the data was transcription of those debates. And these data were collected in the span of 46 years. So we took that data, we built a model, an algorithm for that, and we were able to discover these trends in terms of how topics are discussed over time. And you see things that make sense, that are things you actually that actually depict how we understand historical events. So, for example, this topic about climate change tells you that in the 1990s, the discussion around climate change was mainly about the ozone layer and waste, but that in the 2010s and later, it's more about global warming and gas emissions. And this is exactly what we know about the language around climate change. If you look at another one that I like was human rights. In the 1970s, it was mainly about equality, but now in the 2010s, you also see gender being a huge part of that discussion. So you learn these from society, from that data set. You can do a lot of more things. You can learn to predict the next word in the sentence, and what that allows you to do is to do completion, sentence completion. For example, in your phone, when you type and the phone suggests the next word, that's the machine learning does that. So it can be very useful in assisting people and just making their life easier. You can learn to draw new faces. And the reason why this is helpful, some artists sometimes, if you don't do it for faces, you can do it for other data sets. And some artists, usually they can get assistance from these AI models, because these AI models can generate new outputs that they can now build from. So you can also use this newly generated data, newly generated faces, and add that in your data to train other models. That's what's called the data augmentation. That's also useful. Or they are used, sometimes generative models are also useful in model-based reinforcement learning. That's a bit more technical. This is an example of using AI for arts. And there are many other applications, chemistry and biology and the sciences in general, like physics, neuroscience, but also in healthcare, in robotics, and in recommendation systems. Yeah, so it has many applications. So my thesis work was about making this process flexible and interpretable. Usually it's when I was doing my PhD, the contribution in the field was either focusing only on flexibility at the expense of interpretability, or focusing only on interpretability at the expense of flexibility. So my thesis was trying to devise models and algorithms that allow you to have both flexibility and interpretability. So that's what my thesis was about, deep probabilistic graphical modeling. But I'll move next to my work through the Africa I know. I talked about my journey from Senegal to France and then to the United States, World Bank, and doing my PhD at Columbia and discussing generative modeling, which is what my thesis was about, making generative modeling flexible and interpretable. Right after my PhD, I graduated in May 2020, and started the Africa I Know May 23 days later, on May 23rd, 2020. And the goal still is to promote STEM in Africa to young Africans, because I think that STEM fields, including AI and economics and things like that, healthcare, all of that, I think those are very empowering. And I think developing Africa, sparking the development of Africa will go through STEM fields. The goal of the Africa I Know is to do that, but also with the goal of just overall changing the narrative about Africa. The reason why I'm saying that is because ever since I left Senegal, I noticed that people don't know much about Africa, and the little they know is, the negative stereotypes that are portrayed in the media. And when you look at the media, when Africa gets brought up, anything related to Africa, it's either negative, or when it's positive, it only focuses on, safaris or arts and aesthetics, which is great, but that's not the whole narrative. There are also African innovators, Africans throughout history up to now, contributing greatly to these STEM fields, but they are not highlighted enough. And so the Africa I Know is a platform for Africans and people of African descent to just highlight all our positive stories, just so that there's this other side that doesn't get represented enough in the media and on the internet. And so the Africa I Know has 3 pillars: inspire, inform, educate. So inspire is the pillar where we run projects with the goal to inspire young Africans. So that involves interviewing Africans who had successful careers in STEM fields and asking them questions related to any advice they might have, lessons they learned throughout their journey, what they would have done differently, what they advise to the youth, things like that, and explaining also their field, explaining in detail what they actually do, so that if you're a young African reading that interview, you will be able to discover a new field if you didn't know about it before, and also know the type of job that you can get when you follow that field, and get some advice from actually an expert, someone who made it in that field. So that's the reasoning there. Inform is about writing or content about anything related to technological innovation and advances in Africa. And the reason why that pillar is necessary is because, okay, you read the interview with this person who succeeded in STEM, but you need to see actually how that is leveraged in the real in on the continent to actually impact people's lives. And in the informed pillars goal is to highlight those advances. And educate is the pillar related to, content around anything educational. So African history first. We started with African history because, in order to build for the future, you need to understand history. And the reason why that is important also is it gives us an opportunity to rewrite and correct all these misperceptions and false narratives that have been written. This pillar serves for that, but it also serves as a platform for resources, giving educational resources to young Africans so that they can actually build for the continent. So we have a website, theafricaknow.org. We have a new website actually coming in, because this one doesn't have as much content as the one we're building right now. It's just updating this one with more content and reflecting on all the new projects that we have coming up. So like I said, we do write about interviews with Africans who have succeeded. For example, this lady, and these people usually they're not, you wouldn't see them in the media like that, even though what they have done is truly outstanding. You see Temilola Lolua Priolo, who's an assistant professor at Dartmouth College, who actually is the first Black woman tenure track faculty in computer science in the Ivy League, which is a big deal. But there was no article about this fact about her in the media. We were the ones to highlight it. So these are the types of stories that we bring to the public and for young Africans to see. Young Africans and people of African descent, we do write about, like I said, the informed pillar, what's highlighting African capability. We do write about African history. There's already some impact. For example, this lady from Zimbabwe who really enjoyed our article on Pemba Effect, which is a scientific phenomenon discovered by a young Tanzanian high school, and that's still being studied in the literature. So she said, I shared this article with my son and he now wants to do an experiment. So just by writing this content and highlighting these stories, you can see you never know who can read it, and it changes how they view things or what they want to do. For most of the time, it's not that people cannot do, it's that they don't have the information for what they can do and what they're capable of doing. And I'm hoping that the Africa I Know will be a platform for that. So you can already join the team. You send an email to contact@theafricaknow.org or go to the website and click on the join the team to fill out the form, and we will reach out. We will reach out to tell you more about the Africa I Know, learn more about you, and see if there's a match for what we look for in the team. There are many roles. There's people who translate our content, people who write the content, those are called the contributing editors. We have social media people who handle our social media. We have people who make videos. We want to go into audio and many media format. And we have senior historians. Those are African professors who studied, who are experts in African history, and they write articles for us. They also advise us on topics to write about. And we also have, newer projects like a project about recognition lists. Like you can imagine the Forbes list that you view. We did the same for TAIC. We started TAIC 54, which is a set of recognition lists, one that recognizes inspiring Africans, and one that recognizes organizations that have been very impactful in the continent. So we have projects that are ongoing and that you'll see on the new website very soon. We are on all social media, Twitter, Facebook, LinkedIn, Instagram, with the handle @the Africa I know _ at the end. And we also have a YouTube channel where we, host some of our events. We had an event during Africa Day called the Africa Day with Taik that was very successful. And also just marking some very important dates like Juneteenth, for example, and things like that. So I do hope that you join us. If I can close, I'll close with some advice. If you want to get into machine learning, these are the subjects that will be like the fundamentals that will allow you to be successful: linear algebra, calculus, optimization, probability statistics, and coding. Coding is very important. That's why I put it in a bigger box. Learning Python, Shell, Git, PyTorch, which is an auto differentiation tool that's very helpful. PyTorch or JAX, and cloud services. Lessons is that get mentors. Mentors doesn't mean that you do everything they say. It just means that you have an opinion for any decision you want to make, or ask them if they know about any opportunities or things like that. Get involved in collaborative projects. Get involved in things that are group projects, but also keep focused, meaning know what you're contributing to that group and make sure that your contribution, you don't dilute what you actually wanted to do in your life. So get involved in collaboration, but know that you have your own perspective and own thing going on. Apply to things. A lot of people don't apply to a lot of things because they think they are not qualified. I always prefer to apply to things that I like and let people decide if I qualify or not. If they say I don't qualify, fine. I did what I applied because I wanted to get that. If they say I'm qualified, then that's great. That's an opportunity for me. So I always advise to always apply. Don't underestimate yourself. Don't think you are not qualified. Get internships. That's good for building a network, having people to collaborate with, and just putting yourself out there. And finally, don't feel like you need to conform. Sometimes we portray scientists as a certain way. Don't feel like you have to fit into what that way is to be a scientist. You can just be yourself and follow what you love and who you are, and don't think you need to change who you are to fit in any field. So that's all. Thank you.
Well, thank you so much, Dr. Dieng, for presenting today and giving such an inspirational presentation, inspiring us through your story. And thank you so much to everyone who tuned in to this live stream with Dr. Dieng. It was such an amazing presentation. Thank you so much, and best of luck in your research. Have a great day.